I'm a huge admirer of what Stan has achieved. For me, he's been the most innovative computer-based researcher in geography over a quarter of a century, and that's quite a claim. His influence continues through, of course, through his publications, through the tools that he's created, through his students, of course, and through his example.
I thought I'd just show you this bit here, which has got some of the artefacts that were introduced in the session. This AM/FM was mentioned by our eminent physicist Peter at the end of the talk, and here he has highlighted I have a digital version of this and some of the important contributions there that you saw that Stan made. We have Divinity, and this Maps and Diagrams book was presented to Stan from Argyle House. He shared Divinity, which was the thing that he was perhaps most proud of. An undergraduate dissertation work, which is about South East Lothian. It's brilliant. I've looked at it through. There's loads of pictures of the area, and he went out and surveyed and talked to the farmers, and he talked to all sorts of people in the towns, did various surveys for it. As an undergraduate dissertation, I would be very proud to get one of these from one of the students doing geography in Leeds, but it's an amazing work. This is just a quick look at it. Then we have PhD, and that is a weighty tome of work, and there's lots of folded parts of it, lots of interesting maps on the morphology of areas, and lots of maps and diagrams and stuff in it. But again, it's a brilliant read for anybody who wants to read that stuff. And this, this is generated, was it 1973 or 74 it was awarded, so this sort of stuff is probably state of the art for its time.
This journey has only one purpose: to dispel fears about the transport of nuclear waste by rail. The aim is to show that it can withstand what is perhaps the worst kind of accident it's ever likely to encounter.
Seascale village, with a population of 2,000, is just a mile and a half from Windscale. Here, since 1950, the year that Windscale began its operations, we found 11 cases of childhood cancer.
If we accept the circumstantial evidence, Seascale seems almost like an open and shut case. But is it? This is another northern town, this time in Northumberland, the little mining town of Ashington. And it was the site of another leukemia cluster. In this group of narrow terraced houses, 5 people died of leukemia in the space of just 3 years. What was the cause? Once again, no one really knows. But one thing is certain: it wasn't nuclear power, because this leukemia cluster occurred in the early 1930s. The point I'm really trying to make is that leukemia clusters in this country aren't widespread, but neither are they rare.
Well, now we're going to look at observed data. This is real occurrences of children with leukemia by wards in the northern region. And the wards have been ranked in terms of their unusualness. So the wards that appear first are the ones which have a leukemia occurrence rate, which is very unusual.
What we do here at GeoDen is quantitative geography, or GIS as we call it now. It started in a nice way, because the whole start of this company is based on, let's say, on our friendship. Because what we did together was using geography to solve problems in society. And that was also one of the aims we had. The difference between Stan and myself was that Stan was a real scientist.
Once the North East RRL was brought in, they were able to produce a highly sophisticated GIS, the Geographical Analysis Machine, or GAM. It showed the groupings or clusters across northern England, and there were some unexpected results.
Previous work on childhood cancer had been looking around nuclear installations, because there's some theory that suggests it might be causing childhood cancers. But they don't really know. No one really knows what all the possible sources of environmental contamination that might be causing childhood cancer. So what we've been doing is examining all locations, treating each location in the same way, in a totally unbiased and prejudiced manner, trying to find those areas where excesses exist.
I first met Stan when I went to Newcastle University in 1986 as an undergraduate geographer and mathematician. and Stan was the unusual lecturer, the one who wasn't like all the others. I then went on to do a PhD with him from 1989 until 1991, and that was great, but again, very different from what's normal.
37 years ago, just over 37 years ago, that I stepped through the doors of Newcastle University as a raw undergraduate, and little did I know that my life was to be changed forever. When I went, Stan said, the very first lecture I remember, there was Stan and Alan Gillard, and they rehearsed their credentials for teaching us planning. And Stan intensely proud of the fact that he got the Divinity Prize at school, and that meant a great deal more than the PhD. He went into a glittering career here into planning and a lecturer in the Department of Town and Country Planning. And it's this anonymous building that Stan had an office which he never actually managed to get into most of the time, and he inhabited a little cupboard with a rather strange computing machine and wove some fantastic spells over the next few years.
Oh, did I ever get the impression that Stan thought I should or could work harder? No, not with me, because I was a workaholic at the time. I got to know him best, and I was working 6.5 days a week, and it was silly. What I did get the impression from Stan was he saw no problem with this. He didn't have any problem with somebody working 6.5 days a week, 12 hours a day. So yes, I suspect if you weren't in that situation, you probably thought you should be working harder.
I first met Stan, first encountered Stan, meeting wouldn't be the right word I suppose, at the second academic conference I ever went to at the Institute of British Geographers annual conference in Southampton in 1981. If any sort of alumni as I remember it, it was a year it snowed and everyone sort of really got snowed in. And there was an applied statistics session in quantitative methods at which Fred Smith, quite an eminent statistician at the University of Southampton, gave a talk, followed by Stan wearing a bomber jacket. Do you remember bomber jackets? And the end of the talk, really, Fred Smith said, well, you know, you're not measuring anything. And Stan said, yes, I am. And Fred said, no, you're not. Stan said, yes, I am. No, you're not. Yes, I am. No, you're not. Your parents had no children. Yes, they did. And so it sort of went on like that. And this was the first conference. This was my first sort of experience as a sort of young graduate student. I thought, well, you're really going to have to toughen up in this life.
One of the other things you don't know about Stan is he's actually a magician, because he managed to turn me into a geographer, and that was really quite good, because I came to study a PhD with degrees in mathematics and medical statistics, no experience of geography whatsoever. So anytime I ever think like a geographer or give some sort of impression of being a geographer, that's probably thanks to Stan.
My first impressions of Stan was that he was mad, that this man is mad. He was excited. He was excited at doing a lecture to a load of undergraduate students he'd never met before. It was almost as if he was on something, but he waved PowerPoint after PowerPoint over the slide and kind of almost danced around the room. And that was very different to what was normal in the 1980s from a lecturer. We still had lecturers back then who would dress up in their university gown, put their mortarboard on occasionally, and draw in chalk on a blackboard. So Stan wasn't like that.
There's a big pile of overheads about this big, and he expected me to give a lecture. So I started. So, I said, oh yes, GIS, it's a global technology, and I started. And I followed Stan's slides. Oops, that's a slide. That didn't really matter because I just couldn't do it. I was flying with it. And eventually I was just... Somebody's got to do this, haven't they?
Rather unusually, we're not sitting in a pub having a conversation over pints of beer. And I think one of the things that you observe about Stan over the years is tremendous energy and his tremendous enthusiasm, and I've always felt that's an inspiration.
He was incredibly innovative. He could come up with ideas I could never think of on my own. And not only was he innovative, he was incredibly enthusiastic. And I think the enthusiasm carried the innovation through to an extent that it really made a lot of changes to the way people thought about geography.
We're also thinking about new methods, new ways to do things, new ways of actually approaching our geographical problems. And so I think we got introduced to a lot of new methods. And probably most importantly, in the culmination of all of that, loads and loads of new ideas as well, as I say, mainly emanating from Stan.
The other projects I worked with Stan involved looking at cases of childhood leukemia from 1966 to 1986 across the northeast and northwest of England, looking for cancer clusters in these things and seeing if they could be found. I looked at change over time in the censuses. He had the 71 and the 81 censuses.
How do these people go about their job? They're charged, remember, with ensuring that none of us is exposed to unsafe levels of radiation. That only includes radiation from the nuclear power industry. Medical radiation and natural background radiation is not part of their brief. Now, clearly they can't go around and examine all of us, but they've come up with a very neat solution. They've identified groups of people who, by reason of their lifestyle, and particularly the kind of food they eat, are exposed to much more radiation than the rest of us. And by monitoring these people very closely indeed, and ensuring that they stay within the permitted levels, then, by definition, the rest of us are okay. Now, they call these people critical groups.
Over the years, these critical groups have changed. A few years ago, the scientists studied people who ate lava bread made from seaweed, which concentrates the radioactive elements. Nowadays, they're mainly interested in people who eat large amounts of winkles. They focused on this group, about 30 families who live on the Cumbrian coast, because a detailed survey showed that they were getting higher doses of man-made radiation than the rest of us. Although it's still important to underline, they're getting much less than the maximum permissible limits. Now, these people enable the scientists to monitor whether man-made radioactivity in the environment is being kept low enough. If it turned out, for example, that the winkle eaters were getting doses near the permitted limits, then the releases from Sellafield would have to be reduced.
Champion, get him out of there, stop.
Stan always had the ability to think big and think out the box. So small classifications of EDs in Tyne and Wear became larger classifications of EDs in the northeast, ward level classifications for the whole country.
One thing I remember with me is his best trick was to argue with me a lot, and I sometimes now get cross with my own PhD students if they don't disagree with me enough, because I think the disagreements brought the ideas forward, and it was quite an unusual sort of teaching method that I experienced there, but I think an incredibly effective one.
Stan's last work was all done at Leeds. He was always, in a way, an outsider at Leeds because he hadn't been there that long, and he came in already with reputation. But he did get more and more acceptance as he carried on at Leeds, and he built up a large lab and a large group of people and brought in an enormous amount of funding. And one of the problems the department had when he had his stroke was how on earth they dealt with all this ongoing work that had to be done.
So what are Openshaw's 3 principles of geography? Right? And these are things that perhaps we can carry forward and apply in our own work in the coming years. So number 1, experiment. We've heard a lot of reference to experiment over the last hour and a half. Play and have fun. There's no clear distinction, I think, between having fun in the Openshaw world and doing serious work. Both merge into one whole.
Geographers have suddenly found themselves with a dynamic new role to play, collaborating with other social scientists, statisticians and computer scientists. And potential commercial clients are now becoming more aware of how GIS can work for them. The 8 regional research laboratories already offer an invaluable service. Fully supported and properly funded, they'll create a network of excellence, dedicated to making businesses and government more efficient.
It's a tool for everyone. I mean, what we're talking about here are techniques which can analyse any sort of geographic data wherever it comes from. It'll be used, we're doing some work with the private sector, we're doing some work with the public sector.
One of the things I'm proud of at this moment is that 2 years ago, together with my son, I published a book about the role of GIS in science. Because one of the things I'm convinced of, and that was also one of the things I was doing together with Stan, is that the use and the application of GIS is something which you can compare with statistics. Because in every science people are using statistics. And what we see at this moment is that in a lot of scientific disciplines, they are using GIS. That means quantitative information and quantitative methodologies and methods, which are coming from GIS, from geography, from STEM.
Secondly, be useful. Study real problems. Make sure that what you're doing is well motivated. All of Stan's work, I think, admirably exemplifies that principle.
I'm trying to show you, say, combine this all together, dynamics, heterogeneity in an example of transport study through our recent project I'm leading on. This is working with Transport for London. So for that, we're trying to make journey time prediction, short time, long time, and trying to do early detection of traffic congestion. So if we start from Google, I'm sure you must be used to it. Google now able to show you what happened in the past and what's the real-time situation in transport, traffic. So what do we do? So we're trying to look ahead. Can we make a prediction based on the historical data and the real-time data to look ahead? What happened 5 minutes, 50 minutes, half an hour? So another thing, say, trying to get understand the traffic, emerging traffic congestion. So we use spatial temporal scan statistics, trying to understand where the traffic most significant event happening on the network. This is just one example showing that today. But nowadays we use GPS a lot in different forms, mobile phones, iPhone smartphones. So what do we do? Use also region. This is showing you the GPS dot, and then we move to see how we can understand hybrid mode of transport. We use machine learning approach. Okay, so this is basically, you can see this area is really UCL. This is only able to show 21 because we use the resolution of the image.
And then third, and perhaps most important, challenge assumptions, blow up the boxes, and in a very characteristic Openshawism, all previous work is wrong.
It is very dangerous to ignore this problem. And of course, she said zoning system is a key part of GIS and scale is a key unknown in the zone system. But, I think
the world that Stan fought for in the best sense, a scientific approach, evidence-based and replicable tests, demands data in profusion. We now have it in a way we didn't have 20 odd years ago. We now have it coming out of our ears from automated systems and sensors of one kind or another.
I just wanted to give a few sort of prospective views of how I think what geocomputation has achieved, and to look prospectively to the future. I think we can say, sort of over the last 15 or so years, the achievements really boil down to a vastly improved cross-sectional analysis, describing the repeated analysis and simulation of spatial distributions for exploration and for inference. And then the second main theme, I think we can perhaps refer to the work Peter Atkinson's done, for example, at Southampton, amongst others, is that geocomputation is fundamentally about dynamics, the simulation of processes operating in the geographic domain. And as time has gone by, we've seen fewer idealized curves, Sierpinski gaskets, polar functions masquerading as clouds, sine waves masquerading as landscapes, towards actually geocomputation has become geo. It's become fundamentally about the third rock from the sun.
One day, the default case, the normal case in at least all of the sciences that deal with phenomena embedded in space will be the spatial case. It will be the assumption that spatial dependence is always there, that spatial heterogeneity is always there. And that's a very, very different world from the one that we grew up with. So that's an area I think that Stan has made enormous contributions to. It's one example of how he has changed the questions, as Chris Brunsden said earlier.
I think, as I say, my striking impressions of Stan was his ability to point out when people were asking the wrong questions, and also to come up with new ways of answering the right questions when he worked out what the right question actually was.
Scale actually is not a problem, it is an opportunity. Yeah. And modifiable and unit problem is really for all the spatial data. You can ignore it, but there's a problem. Okay.
And I think that's very important to characterise the way Stan looked at things. He quite often say, well, actually, no, everyone's not really approaching this in the right way. They're asking the wrong questions, they're doing the wrong things. And the response to this is to try to set up some kind of new approach, new way of doing things. Is it still having influence? Well, yeah, this is an article from 2011 about using zoning systems based on Stan's thoughts about the effects of zoning, in this case for designing zones for the 2011 census.
When you read through Stan's list of publications and the work that he's done, it's the sheer energy, which David's already alluded to, and it's the sheer breadth of Stan's interest. Paddy Whitehead at Newcastle asked Stan to automate a technique which led to the decision optimizing technique, interlinear programming to solve planning problems. When the micro came along, DOT became microdot.
I remember there was a presentation that he gave where he did throw up a big picture of someone's butt. It was one of the things that very quickly got thrown on the floor.
Between when I first met Stan in the late 1980s and when he had his stroke, no, he didn't change much. If anything, he became, I'd say, sort of slightly more childish over time, maybe more confident, so he didn't have to pretend he wasn't anything he wasn't. He became more enthusiastic for his work. He probably worked even harder, which may not be a good thing, but he couldn't stop himself.
It was a big change, and the other big change was, of course, after the moment that Stan became ill and he had his stroke. I met him only once after that, and at that moment I understood completely that it was a different person, let's say, in the way that he was not able to communicate, and that he, of course, he could communicate, but in a different way, and yeah, then it becomes difficult.
I suspect Stan's work and what he did wouldn't be appreciated a fraction as much as it is, but for the stroke, it's, yeah, people step back, look and say, oh look how much he did, look what an effect it has, and so on. And that doesn't happen when something like that doesn't occur. And of course people are preoccupied with the everyday kind of fights and my kind of geography is better than your kind of geography thing. When something as dramatic as a stroke of that severity happens, it does cause people to stop and look and appreciate in a way they didn't.
You have all the memories and you have all the nice things which you have done together, and now I have to say that I also was a little bit afraid. I didn't know how to behave and what to do, and at that moment you come to talk with friends and colleagues instead of having direct contact, because especially in the beginning that was not possible. So for me it was an unbelievable big change. And then there are many excuses not to go to England or not to go to Leeds or not to go to Stan. And that makes it also difficult at this moment to think about that, because you immediately feel guilty that you have not done it. But that's life, I think.
It's my painting that Stan presented me with. Stan Openshaw, 2009. He presented that to me yesterday for my efforts in organising the session. Didn't realise he was quite such an artist.
Stan had friends all over the place. He had friends all over Europe. I remember with my PhD thesis, I gave him a copy of it when it was almost finished, and he was going to a conference somewhere in Sweden, and the plane was delayed, he told me, and so he took the manuscript of my PhD and he handed it out to all these people waiting at the airport who were probably waiting to go to the conference. And I got it back with all these scribbles on in different handwriting from lots of, and these were Stan's friends, these were people he knew, dozens and dozens of them he just was sitting in an airport with. So he knew lots of people, and he was very gregarious and very sociable.
Unaccustomed as I am to speaking, and having lost my overheads, I've got some paper instead. I had to find the 1936 wedding etiquette manual in order to get the opening bit, which says, "Ladies and gentlemen." I'm very glad to have you all here today and to share with me and Chris the happiest day of our life. Well, second happiest day. I think the happiest day was when we got together. This is our second happiest day.
I met him later, or when he came with his new girlfriend to Enkhuizen, where I was living. Something changed. Not only, let's say, his friends, but also the music. Because it was not any longer the classic music, but became heavy metal. I have a personal message. First of all, Stan, I'm very happy that I have this opportunity to talk to you. Of course, in a stupid way by using this movie.
Stan, it is a very great pleasure that I had the opportunity to chair the session organized in your honor.
The thing I'd like to say to Stan, I think more than anything else, the thing I remember him for most, is simply how kind he was. When I started my PhD studies, the first meeting I had with Stan, I had to tell him that my younger brother had just been killed and another member of my family had died. And I remember him looking slightly shell-shocked at this, and I remember him saying that he had a sibling and he wouldn't know what to do if they were killed and so on, and he mumbled on a bit more in the way that academics do whenever this kind of thing comes up. But he said if there's anything he could do to help, he would help, and if I just wanted to throw myself into work, that was fine.
I'm extremely honored to be here today to show the inspiration actually through Stan's publication.
Coming from the other side of the Atlantic, I can say that all of this, all of Stan's reputation that we've heard about today here is also true among American geographers.
People realized he had a very strong message of the importance of geography.
One of the other things you don't know about Stan is he's actually a magician, because he managed to turn me into a geographer.
Stan had all kinds of friends. So he had friends for playing cricket, but he also had friends for going to the pub.
I have some memories of consuming large numbers of pints of beer when problems were particularly difficult. We always got a solution, it's just we couldn't remember it thereafter.
I'd also like to thank Laurie, the chief bridesmaid, for organising the bride so well. I hope she's going to tell me how to do it later.
You have to get out the dress later. He's not wearing one.
And then the two bridesmaids.
Stan was very vocal. If he didn't like something or thought it was rubbish, he would say it's rubbish, which is not normal in academia.
All our students who are interested in your work, they have to learn, let's say, what it means to talk about the modified aerial unit problem.
And quite often there would be a contrast, so sometimes it would be wrong. Just trying to get you to think in the audience to say, is that right or is that wrong? Is it wrong? No, it's right. It's so hard to do the Stan impression because it was such a practiced skill of this, you know, when everything was on the floor and he'd given the presentation, there was an opportunity for somebody who was a student in the audience to come and help him pick that stuff up. And that's how I got to know him. I used to come down at the talks at the end of it and maybe help him clear up, and that's when I started to talk to him.